Moving on to the first sum. In triangle ABC, right angle at B, AB is equal to 24 centimeters, BC is equal to 7 centimeters. Determine sine A, cos A, sine C, cos C. Moving on to the solution. Let us consider triangle ABC, which is right angle at B. Here AB is equal to 24 centimeters and BC is equal to 7 centimeters. Let us also find the hypotenuse AC. From Pythagoras theorem, we know that the square of hypotenuse is equal to sum of squares of other two sides in a right angle triangle, which implies AC square is equal to AB square, which is 24 square, plus BC square, which is nothing but 7 square. That implies AC square is equal to 24 square, which is nothing but 576, plus 7 square, which is nothing but 49. That will be equal to 576 plus 49 is nothing but 625. That implies as AC square is equal to 625, AC is equal to square root of 625, which is nothing but 25. Therefore, we got the hypotenuse as 25 centimeters. Now, in the first problem, he asked us to find the value of sine A. We know that sine of an angle is equal to opposite side by hypotenuse, which is equal to opposite side is BC here by hypotenuse is AC here. That is equal to BC is given as 7 centimeters and AC is given as 25 centimeters, which is equal to 7 by 25. Now, he also asked us to find the cos A. Here, we know that cos of an angle is equal to adjacent side by hypotenuse, which is equal to, here adjacent side is AB for angle A and hypotenuse is AC, which is equal to 24 centimeters by 25 centimeters. That is equal to 24 by 25. Now moving on to the second bit. He asked us to find the value of sine C. We know that sine of an angle is opposite side by hypotenuse. The side opposite to angle C is here AB by hypotenuse is AC, which is equal to 24 centimeters is AB and 25 centimeters is AC, which is equal to 24 by 25. Now he also asked us to find the value of cos C. That is equal to, we know that cos of an angle is adjacent side by hypotenuse. Here the adjacent side of angle C is BC by the hypotenuse is AC, which is equal to BC is 7 centimeters by AC, that is hypotenuse 25 centimeters, which will be equal to 7 by 25 is the cos C. Moving on to the second sum. In figure 8.13, find tan P minus cot R. Now moving on to the solution. Here he has given a triangle PQR in which the side PQ is given as 12 centimeters and side PR is given as 13 centimeters. Now let us also find QR. By Pythagoras theorem, in right angle triangle we know that the square of hypotenuse is equal to sum of square of other two sides. We can write here PR square, that is hypotenuse square, is equal to sum of squares of two other sides, that is PQ square plus QR square, which implies PR square is nothing but 13 square, which is equal to PQ square is nothing but 12 square plus QR square, which implies 169 is equal to 12 square is 144 plus QR square. That implies Now on transposing 144 to left hand side, we get QR square is equal to 169 minus 144, which is nothing but 25. That implies QR is equal to square root of 25, which is nothing but 5. Therefore we got the QR as 5 centimeters. Now he asked us to find the value of tan P minus cot R. So let us separately find the values of tan P and cot R. Tan P. Let us find the tan P value. We know that tan of an angle is equal to opposite side by adjacent side. The side opposite to P is here QR by the adjacent side here for the P is PQ, which is equal to the opposite side QR is 5 centimeters and PQ is 12 centimeters, which is equal to 5 by 12. Now let us also find the value of cot R. We know that cot of an angle is nothing but its adjacent side by opposite side. The side adjacent to R is QR by the side opposite to angle R is PQ, which is equal to 5 centimeters by 12 centimeters, which is nothing but 5 by 12. Here he asked us to find tan P minus cot R, which will be equal to 5 by 12 we got tan P, and also cot R we got as 5 by 12. 5 by 12 minus 5 by 12 is equal to 0. Therefore tan P minus cot R is equal to 0. Moving on to the third sum. If sine A is equal to 3 by 4, calculate cos A and tan A. Now moving on to the solution. He has given the value of sine A, that is 3 by 4, and asked us to find the value of cos A and the value of tan A. For this, let us consider a right angle triangle ABC, which is right angle at B, and let angle AB set an angle, and C is also the angle of the triangle ABC. Here he has given that sine A is equal to 3 by 4, which is nothing but, we know that sine of angle is nothing but the ratio of its opposite side by hypotenuse. Here the opposite side of angle A is BC by the hypotenuse in this triangle is AC. Therefore we can write BC as 3 here and hypotenuse AC as 4. In order to find the values of cos A and tan A, we also need the adjacent side of angle A, that is nothing but AB. Here by applying the Pythagoras theorem in triangle ABC, let us find the value of AB. By Pythagoras theorem we know that the square of hypotenuse is equal to sum of squares of other two sides. Here we can write that AC square is equal to AB square plus BC square, which implies AC square here is 4 square, that is equal to AB square plus BC square, nothing but 3 square, that implies AB square is equal to 4 square, that is 16, minus 3 square, that is 9, which is equal to 7, which implies AB we get it as root 7. Now we got the AB value as root 7. Now he asked us to find the value of cos A. We know that cos of an angle is equal to the ratio of its adjacent side to the hypotenuse. We get cos A is equal to, Here the adjacent side to angle A is AB by hypotenuse is AC, which is equal to AB, here we got it as root 7, by AC is 4. And he also asked us to find the value of tan A. We know that tan of an angle is its opposite side by adjacent side. Here the opposite side to angle A is BC by the adjacent side to angle A is AB, which is equal to 3 by root 7. Moving on to the fourth question. Given that 15 cot A is equal to 8, find sine A and secant A. Now moving on to the solution. Let us note on the given information that 15 cot A is equal to 8. That implies cot A is equal to 8 by 15. Let us assume a right angle triangle with A as base angle and B 90 degrees and C be the other vertex of the triangle ABC. In this, he has given that cot A is equal to 8 by 15. We know that cot of an angle is nothing but the ratio of its adjacent side by opposite side. We can write cot A as the adjacent side of angle A is AB here by the opposite side of angle A here is BC, which is equal to 8 by 15. So here we can write AB as 8 and BC as 15. Now in order to get sine A and secant A, we need to find the value of AC, the hypotenuse. Now by applying the Pythagoras theorem to triangle ABC, we know that the hypotenuse square is equal to sum of squares of other two sides. Here we can write AC square is equal to AB square plus BC square. That implies AC square is equal to AB square, that is 8 square, plus BC square, that is 15 square, which is equal to 8 square is 64 plus 15 square is 225, that is equal to 289. So here we get the value of AC as square root of 289, which is equal to 17. So AC can be written as 17. Here firstly he asked us to find the value of sine A. We know that sine of an angle is equal to opposite side by hypotenuse. Here is equal to the opposite side of angle A is BC and hypotenuse here is AC, which is equal to BC is 15 and AC is 17. And in the second part he asked us to find secant A. We know that secant of an angle is equal to its hypotenuse by the adjacent side. So here the hypotenuse is AC by, and adjacent side here is AB for angle A, which is equal to AC is 17 and AB we got it as 8. Therefore secant A is equal to 17 by 8.